Okay, thank you. Good evening once again, everyone, and welcome to um, this class. Today we'll be taking introduction to machine learning one by one, and in fact, we'll discuss the most important part of machine learning, which is data, and we will square on various data preprocessing that you can do while you are working on your machine learning part. That being said, let me cast our mind back to the first class we had, which is the introduction to artificial intelligence. And in the class, we made mention that machine learning is a subset of artificial intelligence. And in particular, machine learning is the developmental aspect of artificial intelligence. In artificial intelligence, quite a number of things comes in: the development of theories, the study of the study of intelligent beings, intelligent organisms, and also naturally occurring intelligent systems. And there's a lot of fields that contribute into artificial intelligence. Fields like philosophy, psychology, neuroscience, statistics, computer engineering, computer science, control, so many fields, mathematics comes in together to form AI. But when we talk about the implementation aspect of the AI, that is development of softwares that actually perform AI task. That's that aspect, that algorithmic aspect is what machine learning focus on. So we will begin our fundamentals of machine learning today. And today, this is going to be our agenda. And so when we talk about machine learning, basically what we do is we get data and prepare the data, then we select model, build model. Um, we have a way of fine-tuning the model and making sure that we select the best model of different kinds of model that we train, and have a way of testing and validating the model, and of course deploying the model into the real world. This is the machine learning pipeline. But today we will square on data preparation, in which we'll be talking about the actual data that you have. So today's talk, we won't bother ourselves on different kinds of machine learning models there is, or how you train your machine learning model. We won't be focusing on how you deploy the machine learning. Rather, we'll be focusing squarely on this first aspect of the pipeline, which is data preparation. So why is data pre-processing or data preparation so important? Um, we have so much data around us. Data is everywhere. The talk I'm delivering right now is some sort of data. You participants, the time you come in, the time you leave is some sort of data. Um, just look around you, whatever you can see there is data. So there's so much data in the world, but the data available in the real world is dirty. What we mean by dirty data is that the data is incomplete. It is lacking in some sort of attributes um, or particularly in the attribute that we are interested on. I mean, that we are interested in. And sometimes it contains only aggregates of data. It's not holistic, it's not complete. That's what we mean by it. A data is um, incomplete. Also, the dirty data also means noisy data. It means it contains error or outlier, or it is covered up by things that we don't want. And lastly, a dirty data means inconsistent data. Data that's containing of discrepancies in code or in names or in arrangement or in the schema of the database, anything. So the data may be inconsistent. So data in real world again is dirty data. And by saying dirty data, we mean that the data is incomplete, noisy, or inconsistent. Now, secondly, why we need data pre-processing is that we don't have quality data, and we don't have quality mining results. Quality decision can only be based on quality data, and data warehouse needs to be consistent needs consistent integration of quality data. Don't forget that the data that is available in the real world is actually a dirty data. Then thirdly is that we have multi-dimensional measure of data quality. That means that we have a well acceptable multidimensional view of what accuracy, completeness, consistency, timeliness, believability, and so many other things that we want our data to be. There's so much view of what a quality data means. The last time that we had AI for FS program in Summit University, Dr. Folorenshaw was talking to us about data, about what a quality data means, and I remember she talked about this aspect very well. And lastly, why we need data preprocessing is because we have broad categories of data. It may be intrinsic, maybe contextual, maybe representational, or the accessibility. But when we talk about data, and we talk about data, it can be a multi-dimensional thing. What we mean by data actually is a lot of meaning packed into one thing. All right. So what are the major tasks in data preprocessing? When people hear data preprocessing, the only thing that comes to their mind is the first word you see there, data cleaning. But data preprocessing goes way more than that, and that is exactly um, why this class is very important. I always want to take a good look at data. I always want to have a real discussion around data before any real machine learning task can take place. If you approach me and say you have a project, you want to use AI, the first question I ask you is, do you have a data? What kind of data do we need? And that is why this class is very important. Okay, so when we talk about data preprocessing, these are the major tasks involved. We talk about data cleaning, data integration, data transformation, and data reduction. We will look at each one of them specifically in this class. So when we talk about data cleaning, we must come up with a method of filling in missing value, smoothing noisy data, identifying or removing outliers, and resolving inconsistency. So that is what we mean by the cleaning process. Now, we also talk about data integration. That is bringing in together different databases, bringing in together different files, different nodes into one thing because we want to make sense out of it. Then we also have data transformation, which is data normalization. That is, you want to scale the data to fit a particular range. You don't want some dimension of the data to take on some arbitrarily long, wide range of value, whereas another one is narrow. So in that case, you want all the values to be equally in the same range or the same specific range. Then we also have data aggregation. Also, is more like data integration. We look at it in individually in this class. And the last one is we have data reduction. So many times the data you obtain is voluminous, but um, because it's voluminous does not mean that it is actually the whole thing that you need, because it produces the same or similar analytical result if you were to compress it. And some other times, discretization is important. You want, especially for numerical data, you don't want the data to just take some arbitrarily number that is going to take up all the memory you have. All the computing memory that you have to spare. So let me give a life scenario where this comes into play. Many of us will not forget the COVID-19. What happened during COVID-19, and maybe many of us are not quite aware of what I'm about to say. But during COVID-19, the coronavirus was so new that clinical knowledge that we have is kind of fuzzy about the virus. So um, then we discovered that because the pandemic hit the whole world at the same time, different people are working at different parts of the world and they are producing results. And what they are, I mean, they are publishing their results, and what they are publishing, whether in China, it is also equally useful in Nigeria at the same time. And what is publishing in Nigeria is equally useful to them in Australia, or Germany, or Argentina. So the US government released a grant around that time that's just what the grant is all about is that every paper published, every mention of COVID-19, whether in Twitter or in Facebook, all of this pool of data should be aggregated together. Now, when you say all of this data to be aggregated together, you're talking about data from different parts of the world in different languages, data from both experts and non-experts. You're talking of data from whether a verified result or unverified, whether a peer-reviewed journal or not. So they are getting all of that together. So data pre-processing comes in even before you start thinking of an AI model that is going to make sense out of that corpus of data. So data cleaning comes in to say, yeah, what are the noise? What are the result that is inconsistent? What are the result that is unverifiable? Let us remove those ones. What are the values that is missing? Whether this person begin to say an important thing, but then along the way, he didn't say some other things. Is it possible that somebody from different part of the world or different lab is filling in into what this person failed to say, and then integration comes in into saying, yeah, this data is coming from Twitter, this one is coming from Elsevier, this one is coming from Facebook, this one is coming from Germany, this one is coming from Nigeria, and you integrate all of those data together. Different databases, different different files, whether it is text file, whether it is image, all whether it is voice notes, they bring all of those things together. Now, data transformation will now be like, yeah, okay, so we need to normalize this thing. So we also talk about in this class, we also talk about how do you transform text file into a numerical file. So something that we call word embedding in natural language processing. So all of those things come together. And lastly, is data reduction. When you talk about this case of COVID-19, now you imagine the number of paper published, the number of tweets that was tweeted in the whole 2020, for instance, and you think about different things that were said in different labs and all of that. This is going to be a voluminous data. So you have to think about how do we compress this data? Because if you have too much data, you can't even begin to train the machine learning model from it. So all of these things come together. I believe we understand from this analogy now why data preprocessing and all the tasks involved are so important. Is it clear? Do we have any question before I move on? I hope people are in this class with me.
Yes, sir, we are here with you, sir.
Okay, thank you. Is there any question before I move on?
No, it is clear, sir.
All right, thank you. So, no question. All right, so let's look at data cleaning. Data cleaning, the task involved is filling in missing value, identifying outlier and smoothing out noisy data, and correcting inconsistent data. So how do we undo missing data? Data is not always available. It is not all the data that you want in real life that you always get. Whether you are working on the medical data and you are looking at different form of disease, or whether a particular pathogen marker is present in the image you are looking at, I mean the medical image you are looking at or not. In some of those images it will be present, in some other it will not be present. Or whether you are looking at customer review for a recommendation system. Some customer will give comprehensive review about a particular product or movie or whatever you are interested in. Some customer will not. You know, sometimes you get this database and then this particular entry was not made. So data may be available, but some part of it may not always be available. So missing data may be due to equipment malfunctioning, especially when you are dealing with IoT data, for instance, or when where you need a data acquisition card, an hardware system that is going to acquire the data for you. Missing data also results from inconsistency with other record. Inconsistency with other record, and so it is deleted. A typical example of that is I read an article of recent where they were talking about the first time um, ozone depletion was sensed around the Antarctica. You know, it was so it was so unusual, it was so unbelievable that um, the data cleaning process that they built for that machine, for that equipment, deletes the data entirely. So it is possible that inconsistent appear, and because it's appearing for the first time, it just deletes it, right? So another instance where data missing data may occur is that data is not enter due to misunderstanding, just like this example I just finished giving. Certain data may not be considered important at the time of entry. Yeah, sometimes you go out to collect data and then, especially when you are designing your project, you just think that some data is important, but as you go into the field, you discover that, yeah, you need some more information. Whereas you have started collecting some data. So at the time you start collecting the data, you don't think some data is important, but as you go on, you discover that they are quite important. So missing data may also occur due to not register in history or changes of the data. So whatever the case may be, missing data may need to be inferred. So how do we infer this missing data, or how do we undo missing data? Well, the first one, which is the lazy work, is to ignore the tuple. Usually done when class label is missing. You assume that the task is okay. Assuming the task is classification, you just say that it is not effective. So another method is filling in the missing value manually. This is tedious and it could be invisible, especially when the data is so much. If the data is not so much, of course, one can sit down and manually fill in the record. You know, I work with a group of researcher, medical practitioner, especially from OAU Teaching Hospital at some point, and we were actually developing the mammogram database for Nigeria. And at the start, what they do is they have some RAs, that's research assistant, that will first look at the mammogram and kind of label it. But from that, another layer of control will be some doctors, and finally the last layer is the head of that unit in OA Teaching Hospital. So the head of the unit will look at the data one by one and will manually enter any missing record or any missing detail on the mammogram. So that is possible. It is tedious. It may be feasible for some projects. It may be completely infeasible for other projects. So another way of handling is to use global constant to fill in missing value. So for instance, if you have a unknown class, or what we call NA, that's not available records, when you start working on machine learning projects, you come across it a lot of time. So what we do most of the time is to just fill it with a constant. Probably you just fill it with zeros, or you fill it with ones. So that is filling with constant number. Another method you can use to fill, especially if it is a numeric value, is to find the mean of the um, entire column and use it to fill in the missing value. This is quite good. because the assumption, oh, I may not want to go into so much of this detail, but let me just mention that the general assumption you make when you are building a machine learning data is that, I mean, a machine learning model is that the data are what we call independent and identically distributed data. So it is IID assumption. It is independent, it is identically distributed. So because of that, you can easily model it like a Gaussian, a Gaussian distribution with some certain mean, right? So if you are building your data with that kind of understanding, then you tell yourself that, yeah, if any data is missing, then if I fill in with the mean, it doesn't affect my machine learning model. And that is very acceptable in practice. Another method is to use the attribute mean for all sample of the same class to fill in the missing value. Well, this is quite smarter because you're just looking at the same class. So if I'm looking at okay, the first one, the difference between the two of them is that the first one just look at the attributes, right? What we mean by attributes is let's say that we're trying to we're trying to look at customers rating now on particular movie, and so we look at the time they come to watch the movie, for instance, and then we say, yeah, so some values are missing, the time value is missing for some people, and so we just say, okay, let's find the mean of all the time and put it there. Now the second one is saying, yeah, for all the people that give positive comments about this particular movie, let's look at the time they come to watch the movie and find the average, the mean of that time, and then use it to fill in the missing value for people that also rate that movie as positive. So that is the difference between the two of them, and this actually work much better in practice. And the last one is the most probably value. Fill it with the most probable value to fill in the missing value. That is using inference-based methods such as regression or Bayesian formula or decision tree. So you first apply decision tree or any of these machine learning process on the data itself first to fill in the missing value. Then you now continue to use your data for whatever you want to use it for. All right. So let's look at noisy data. How do you handle noisy data? Of course, we have defined what noisy data means. It's usually a random or random error that is in a measured variable. So and it could actually be incorrect attribute value, um, which is due to faulty data collection instruments, data entry, transmission problem, technology limitation, or inconsistency in naming convention. And then other kinds of noisy data may be duplicate records, incomplete data, or inconsistent data. So how do we handle such kind of data if we have noisy data? How do we handle them? The first method is called binning. What binning means, um, what binning means is that we first sort the data and partition them into equal depths of bin. Bin is just when you partition the data in, just bin come from histogram. When you are forming histogram, you create bin. Yeah, so that's where it comes from. So we say that you first sort the data and then you partition them into equal depth of bin. Then one can smooth by um, bin means. That means each of the partition that you have, you can find the mean of them. And then, or you can also smooth by the median of the mean. So you look at the bin, find the median and use it to smooth. And of course, you can also use boundaries of the bin to smooth. So, and this is also useful for discretization. Of course, we'll talk about discretization very shortly. Then we also have clustering. That's how to handle noisy data. Clustering means that you group similar data together. So when you group similar data together, it will be very easy for you to see outlier. Outlier is a data that is far removed from every other similar data. So you will easily see the outlier that doesn't form it, I mean that doesn't belong to any of the group, and then you know this is a noisy data and you can easily remove it. Um, then we also have some automated methods such as you combine computer method and human inspection. You know, you can have a clustering algorithm, and then you can also have people that manually check to ensure quality control. And of course, you can also use regression method for it. So you see that um, both missing data and noisy data can actually be fixed using regression method. Yeah, then let's talk about discretization. Discretization is, I mean, binning is a form of discretization. And what it is doing is that um, sometimes you have data um, that is categorical. What we mean by categorical is that they form into different classes. You can easily form them into different classes. For instance, we can take a sample of this class. Like I tell you, attendance in this place can also be some sort of data, and we can begin to form each one of us into different classes. Say, for instance, we can look at, yeah, do we have some male people with us and do we have female? That's some sort of category. But then we can also look at how many of them are students, how many of them are maybe researcher. Then even the students, we can further break them into being and ask them that, okay, how many of you are in maybe 100 or 200 level, how many of you are in your um, penultimate or final year level, and then we can ask how many of you just graduate, and probably those that are into their masters, you know. So we can use those different kind of things to form discretize, I mean to discretize our, I mean that's what we mean by different categories, and this discretization is actually partitioned into that. Now, this discretization is quite important, especially when we are dealing with natural language, things that are not words, you know, I mean, that are not numbers, they are words, you know. So you have to discretize the data before you can manage them. Okay. Yeah, don't let me go through. I don't want to go into detail of how to handle any of these methods because some of them involve too much mathematics, which um, is beyond the scope of this class. So, how do we handle inconsistent data? Um, what we can do is to use manual correction using external references. That's manually, you know. An example I can give is say medical record now. Somebody just come up with a, I mean, somebody just come with a diagnosis, maybe using a medical image, and the data is, I mean, what you see in the result of that that scan kind of look awkward. Then you ask the person to go and do histology, you know. So when the person bring histology, then you can use histology to judge your I mean to adjust your judgment on the medical image that you see. So that's some sort of way of handling inconsistent data. Sorry, you hear me using so much of medical image example or medical term example. Sorry, I do so many work on that. But apart from that, this also happen in different kinds of walk of life, you know. So we also have some automatic method using various tools such as to detect violation of unknown functional dependencies and data constraint, or to correct redundant data. Especially this can be if you are using IoT devices. Again, you hear me using this example because that is the area. But regardless of the example I am using, data and how to handle data is fairly the same on I mean, regardless of where you are working, regardless of the area that you major on. So, if you are, for instance, working on IoT data, or you build a data acquisition card, and you begin to see some data is kind of awkward. What I mean by awkward is that um, you are expecting to see the temperature of a particular process. Maybe you are monitoring the temperature in a tank, for instance. Maybe yeah, okay, let me use a typical example that comes to my mind now. Let's say you have an aquaculture system, that's you are rearing fish, you have a fish pond, and you want to monitor the temperature in the water. Of course, you don't want to see temperature of 90 degree, 100 degrees Celsius when you believe that the fish are still alive. So when you see that kind of thing, oh, this data is completely out of it. So you must put in place you must put in place method to handle it. And one of the easiest thing you can do is you can even build an algorithm into your system that will discard that kind of data. So that's what we mean by a semi-automatic way of handling data, by placing data constraint. You just know that this data, 100 degrees Celsius for a fish pond, is completely impossible. So because of the constraints that you have placed on it, that kind of inconsistent data will not be recorded. And also by having this kind of, by having functional dependencies, say for instance, you are working on a um, in an industry. Let's take, which example of industry can I give now? Um, let's say you are working on a chemical industry, and you are monitoring the process, and two parameters that you are measuring, for instance, is pressure, temperature, and and the volume. All these things are, I think, as dependencies. So you know that temperature and pressure and volume, all of them, they are interrelated. And so when you see temperature rising and pressure rising, and maybe the volume is also rising at the same time, something is wrong somewhere. So because they have a functional dependencies, across each other. So in that kind of way, you can handle, oh, no, this data is not possible. And of course, you can use that to also correct your redundant data. Okay, so we have talked about why we need data preprocessing in this class. We've looked at also what data cleaning means. So let's talk about data integration and data transformation. Before I go on, do we have any question? And I hope I'm not the only one in class. Any question? Can you hear me?
Yes, we can hear
Yes,
you.
I will hear you.
Okay, thank you very much. We don't have any question, right? All right.
No
So
question for now.
okay, thank you very much. All right, so let's look at data integration. Data integration. Don't forget earlier, while I was using COVID-19 as example, I told you that data integration can be very, very important, especially when you are having your data from different sources. So data integration actually combines data from multiple sources into a single coherent data form, or which we call store. And we also have schema integration. Schema is talking about metadata from different sources, especially from different databases. It may be some sort of you're trying to do some sort of um, entity identification. So you have identified some real world entity from different sources. So, but these different sources, they will have a naming convention differently. Let me give a typical example. We are in election period, right? And let's say that I'm building a machine learning algorithm that's kind of keep track of what people are saying about a particular candidate. You know, we all know candidates in Nigeria, so that it will not look like I'm saying one for the other. So let me just keep it open that way. So, and then you also know that this kind of discussion can happen, of course, popularly on Twitter. It could also happen on Facebook or on Instagram or on TikTok. It could also happen on YouTube. Now, with this that I give now, the kind of data you see on Twitter is basically text data, right? The data you kind of see on Facebook could be it could be picture or text data. The kind of data you want to see on Instagram is going to be image and video. They use less text. The kind of data you see on TikTok is squarely video, and the one you see on YouTube is squarely video. So how do you bring all of this data together to track what people are saying, people's opinion, about different candidates? So this is where schema integration come into be. So you have an identity problem, you have an identity identification problem, or identity tracking problem, and then you can use different sources of data that is available for you, but then you must be able to manage your schema integration. Very, very important. All right. Then we also have detecting and resolving um, value conflict. Yeah, for same reward identity, reward entity attribute value from different sources are different. So, for instance, okay, just like I just make the example of election and personality tracking now. Um, what you get from Twitter is different from what you get from YouTube. So you must be able to resolve the value. The value is different. What I mean by value is the value of the data. So for instance, the value of campaign on Twitter is going to be, if you search for campaign on Twitter, what you're going to get is text files, you know, but when you do the same thing, what you're going to get is strings, yeah, text. I guess we will go with text much better. But when you search the same thing on YouTube, what you get is video. So the value, you must be able to resolve it. Then possible reason, different representation, of course, different scale, different matrices, different currency. Yeah, this also happened. Well, I just use a local problem now, which is election. But talk about if we are, oh yeah, I also give the example of COVID-19. The metrics they will be using will be different. So the metrics that the British will be using will be different from the metrics that they will be using in what's it called, in the US. So an individual too, when they are talking about the impact of COVID in their local area, in their countries, Nigeria will be talking in naira, China will be talking in yen, US will be talking in US dollar, and everybody will be talking in their local currency. So the value again will be different. So data integration also kind of have a method. It's talking about getting yourself a method of handling and detecting and resolving different data conflicts, especially value conflicts. Okay, so handling redundant data in data integration. That's how do you handle redundancy in data integration? What we mean by redundancy is that you have the same attributes that have different names in different databases, or you see the same thing that is said in different way in different databases that you are trying to integrate together. So what you can do is you can perform correlation. For those that are scared of mathematics, this is actually the formula for correlation, but you don't need to worry yourself about it. But when you perform correlation analysis on this attribute, then you can know, oh, even though this one is bearing the name derived, this one is bearing a base name, this one is bearing a derived name, or these two values, even though they come on different ID, they're actually saying the same thing. So a careful integration can help you to avoid or reduce redundancies and inconsistency, therefore improving your data mining speed and quality. Okay. Yeah, we also have data transformation. Don't forget that these data are coming um, from different sources, so you may need to perform smoothing. We've talked about how do you remove noise from data the other time. We talked about binning, clustering, and regression. And you may also need to do some sort of aggregation, maybe summarizing the data or cube construction. You may also maybe you also need some sort of generalization. That means concept of hierarchy climbing. That means you are maybe forming like this is the base of the problem, then a little bit up there, something like a pyramid, yeah, for generalization. But one of the most important data transformation we usually do in machine learning is data normalization. So you ensure or you force the data to fall within a small specific range of value. And the method we use include min mask, set score, and normalization by decimal scaling. So, and lastly, the kind of transformation is attribute of feature construction. In fact, sometimes it may be that you are even reconstructing new attributes from the previous or given ones. Okay. Yeah, data normalization, like I said earlier, we use min max, set score, normalization by decimal. The formula is what is there. Okay, we're almost done. Just two more topics, and I will give room for question. Um, that is, how do we handle data redundancy? Data redundancy. Sorry, today is just data talk, and I think it's very important. One cannot overemphasize the importance of data, and once you get your data wrong, just forget about it. The whole machine learning process is flawed and your model will not even do anything. Okay, so data reduction. So let's look at this problem. Data warehouse may store terabytes of data. Very complex data analysis mining may take a very long time to run on a single complete data set. So, like I gave you earlier, the COVID-19 case. So there was so much data coming from different people and different places. And so this data mining is, could generate terabytes of data. Not only that, not only COVID give us terabytes of data, you probably will have heard of big data. Big data comes in kind of like this scenario. Let me use scenario of Toyota automobile company. All cars now have sensors, and the sensors can talk back to their company so that they understand what different customers are facing in different parts of the world, and all. So for that kind of car, if you drive the car for like a mile, it's going to get tons of data from maybe from the way it senses the data, the road surface sensing, from the different sensors that are in different parts of the car. Now, this is your own car alone. Toyota has millions of cars that is sold annually. And so if all of this data, all of these cars are sending back information to Toyota, that's going to be voluminous data that is harvested in a single day. So how do we take care of this data to make sure that the number one, the data mining process runs so smoothly, and number two, we do not take all the memory space that is in the world just to do data mining. So the solution, of course, is data reduction. Data reduction obtains a reduced representation of data sets that is much smaller in volume, but yet produce the same or almost the same analytical result. So what we look for is that you look for, out of this volume of data set that I'm generating, which one actually makes the most of the sense. Fine, you don't want to discard data indiscriminately. but then you can look for some features of that same data set that could represent the entire data set much, much better. The strategies of data reduction include data cube aggregation, dimensionality reduction, data compression, numerosity reduction, discretization, and concept of hierarchy generation. Um, let me talk generally on this before we go on. I'll just pick two important three important to talk about. The first one that's always very important is this dimensionality reduction. And what dimensionality reduction does is um, you may be measuring, you may be thinking about a particular problem and think of measuring different attributes about that data. About that particular process that you are interested in. So let's take for instance that I want to build a machine learning process. A machine learning model rather, machine learning model that kind of understand why students fail or pass in, let's say, Summit University, for instance. And there's a lot of things that contribute to student sources of failure. Um, Let me make the problem a little bit more complicated. Let's say that um, um, there is a scholarship that that somebody runs, and he wants me to develop a machine learning model that's not only give the best candidate that scholarship, but it's going to give a candidate or a student, um, let's say a student that we know is going to end up with a first class. And this scholarship, let's say, is given to 100 level students. That's before they even come into school. And the only way I can build that kind of machine learning model is actually to come into Summit University or Summit University is a little bit small and a controlled environment. Let me talk about Federal University of Technology, Mina, which is a little bit more wild. Now, when you come into that case, I'm going to take different levels of students and I'm going to consider different things. Now, some of the things I'm going to consider, which we now form the dimension of the problem, which is what I'm trying to explain, will be, I'll pick the students itself, the student himself or herself, and then I'll ask the question of what are the things that can contribute to the sources of these students. Then we begin to list where is the student staying, off campus or on campus. Depending on that, it's cool. Fatigue could set in and the student will not pay attention in class. Then I'm going to ask the question of what kind of support does he get from home? How much is his monthly allowance? Now, if the student is well fed, may have time to study his book and will not even worry himself about where the next meal is coming from. Then I can ask, okay, does that student get sufficient book to read? Does he have access to resources that he can use to read? Yeah, apart from what the lecturer is teaching in class, is there available material for him to study? That goes also as part of the dimension of my problem. Then I can ask, okay, what about his friends? How many of them, what is their performance, maybe from their secondary school or their performance consistently in the university, and I'm also asked whether the students, what is the social disposition of the students, that's another thing. Making five, I'm counting it for myself if you don't count for me. Then I can ask now about this teacher. We can't leave teacher out of it. So this teacher that is teaching them, is he a professor or a senior lecturer or a graduate assistant or a new lecturer? What is this? What is the rank of the lecturer that is teaching them? Then I can ask, how long has the lecturer been teaching that particular course? Then I can also ask, how approachable or how friendly is the lecturer? If the lecturer is the shouting type, the student may not pay attention, or if the lecturer is abusive type, who, when students make a little mistake, will just abuse them, and in that way kills the morale of the student and they are not ready to learn. Then Is there any other thing I can ask about the lecturer? I don't know whether there's more. Let's say there are more, but I can't think very straight now. Okay, then we can ask about the exam process. When do they write the exam? For us in Mina, if you put exam during its period, especially that March, April, it is terrible. Students will not be able to write very well. So what is the weather condition of that? What is the exam process? How difficult or how simple it is? Then so many things you can ask. Like this that I'm just talking now, I've listed like 10 attributes, and it can be more than that. I have a particular data set, um, cybersecurity data set at some point. It has about 150 attributes, different things that contribute into it, different dimension. So, but then you can ask yourself, which of these is important? Which of these actually determines whether this student will pass or fail? And I can point to you that whether the kind of support the student gets from home arguably does not determine whether the student will finish with the first class or not. Because a student can have 100,000 naira in his account, and that is even going to make the student fail. And the student is going, and another one will be struggling with 100 naira in his pocket, yet it will be a first class student. So we can begin to ask further questions about and say which of them actually determine whether the student pass or fail. And sorry, excuse me, just give me a second. Okay, sorry about that. I had to open the door for someone. Okay, so by following this analogy, you know that there are some dimension of the data that is really redundant, that is not needed. So what dimensionality reduction does for us is to take away those part of data that does not directly affect the result that we want to get. So in the case of the example of a student ending up with first class or second class that I used, what are the dimension or attribute that we are measuring but does not contribute to the sources of failure of the student? Now, using that same analogy that I give you of this dimensionality reduction, data compression also comes into play. What data compression, the logic for data compression is that, do we have a particular salient attribute that could summarize some 4-5 other attributes? Yeah. Do we have just one attribute that can summarize some other 4-5 attributes? Such that if we have that, we have this one attribute that can summarize 4 others, then we can discuss 4 others and keep only one of these. So if you do that, what you're going to result in is a compressed version of your data. We also have numeric or numerosity reduction. This comes especially when you're working with deep learning model. Around that COVID period, myself, Professor Musa, and some other colleagues from Nile University, Abuja, we were looking at the method of making deep learning model, especially deep convolution neural network, to be much more faster, and yet we will not reduce in the accuracy that we get. And one of the things that we stumble at that time is what is called mixed precision training. What mixed precision training means is that there's a precision that is used to represent each data point in the memory, that's in the computer memory. So for instance, floating point numbers are represented with 32 bits IEEE. I can't remember the name of that IEEE number, but they use 32 bits to represent a single number. That's a whole lot of data in memory. Now, if you have to come into deep learning now, where you have so many of such parameters, it could be in millions of parameters that you have, and each one of them is represented with 32 bits. So we look at it, okay, this is a whole lot. This is one of the things that is making people like us from Africa not to be able to train deep learning model because our computer is not strong enough. But what will happen if we have that precision number? So are we going to run into overflow? Are we going to run into a problem? What's going to happen? Is it a round up problem or whatever it is? So we found that luckily enough, some other people are thinking about it, and they suggest what we call half precision training, which is like floating point 16. So they use 16 bits precision to represent a 32-bit. That's like you are reducing half of it. So that is a some sort of numerosity reduction. Well, we can read more about this thing. We wrote a paper on it, optimal hyperparameter representation. If you check Professor Ibinu's Google Scholar page, you'll find the paper there, or if you check mine. But you can also check mixed precision training as some sort of numerosity reduction. I should have included that in. So I'm not going to talk so much about cube aggregation. It does sometimes you may not really need it. Well, I've talked a lot about dimensionality reduction, and I believe that by now we understand what reduction is all about. Well, there are different methods of performing dimensionality reduction. There is heuristic method of doing that, and that is stepwise forward selection, stepwise backward elimination, combining forward and backward elimination, combining forward selection and backward elimination, and the decision tree induction. What this are saying is that, yeah, what you're doing, forward selection, is that you start with a smaller number of features, and then you keep on adding to them one by one. The stepwise backward elimination is that you start with the entire data set, the entire attribute, and you are removing them one after the other. The combination is that you add one and you remove the other, you add one and remove the other, you add two, you remove one, and see what happens. Then decision tree induction is that you train a decision tree classifier. Don't worry about decision tree if you don't know it. By subsequent classes, before we end this training, we will talk about machine learning models, and decision tree will be handled in the class. So, but decision tree model, after you train a decision tree model, you can see how a decision tree build its own induction. How it build its own heuristic by itself. And so you can see how the induction was done. You can see some part of the attributes that that contributes to the performance of that model, and you can see some that doesn't even contribute well, and so you can take them away. So that is a method. Yeah, this is an example of the decision tree that we're talking about. Yeah, but before I leave this place, the other method apart from heuristic model, heuristic model method, we have computational methods like principal component analysis. What principal component analysis does is that it will kind of project the data from your own attributes into another feature space. And then from that feature space, it will kind of look at it and say, it will project it on the feature space and then kind of stand it on this hypercone so that it can perform optimization on it. So that is what principal component analysis does. It uses engine value. Yeah, it does engine value decomposition and then pick the engine. It just pick the engine values, which are the principals of that particular attribute. Apart from that, we have singular value decomposition and some other values that some other methods. Data compression. I've also talked about data compression, but when you talk about string compression now, the method you use is kind of different from if it were to be video or audio, or if it were to be a time series analysis, So they are different, and the method you apply for them is different. But regardless of it, we have found that um, um, Deep learning methods such as autoencoders are quite good in compression for all sorts of data that you may want to. So what autocorrelation does is it basically, it's not autocorrelation. Why am I saying autocorrelation? I'm supposed to say autoencoders. What autoencoder does is it has an encoder mechanism that will encode the data using um, another kind of combination of words. So usually they use neural network to encode your data, and then they have a decoder at the other at the other aspect. What decoder will do is that this encoded message that you have already encoded using neural network, they will now optimize it and try to bring out the salient points or the latent features, and that latent features will now be used to decode the message so that you get back what you put in originally. So if you put in an image, for instance, it will encode the message, the image using neural network, and then find the salient features, find the latent features of those image, and then use that to decode and get back your image. The same thing goes for string compression and the likes. Okay, yeah, this is principal component analysis. I'm supposed to come under that. Sorry. So this is principal component analysis that I was saying. Yeah, so we have numerosity reduction. You can use parametric values that assume that the model, the data fits into some model, and then you estimate the parameter of that method, that model. Then you store only the parameter and discard the entire data. So you can train a model to do that, maybe a logistic model, or even neural network can be trained to do that. So instead of saving the entire model, instead of saying the entire numerical value, you only save the parameter of the model, and that way you save a lot of things. Other non-parametrical method is you don't assume any model, but you can use clustering, sampling, or histogram to do the work. Yeah, so these are the methods. I don't want to go into so much detail of each of these. Yeah, so the last thing we want to talk about, so that I can give time for question and answer, maybe not necessarily on what I cover. Maybe you have worked with so many data and you want to ask question of maybe outside what we even discussed tonight. It's possible. Let's discuss as machine learning experts. I'm not so much of expert, but I can also learn from you. Okay. Yeah. So we have three types of discretization or quantization, as it's also called in signal processing. We have the nominal, where values are from ordered sets. We also have ordinal, where values are, nominal is from unordered sets, ordinal is from ordered sets, and we have continuous, which is from real number. So what you do is you divide the data into range of continuous attributes into intervals. So like the image that we have. So then you apply some classification algorithm only on acceptable some classification algorithm only accept categorical attributes. Of course, we have them so many. Neural network only have it only accepts categorical as attributes, or if you are doing classification, the same with and most of these classification models, they only accept categorical, they only give you output of categorical attributes, and some other time you want to reduce the data sets by discretization, we have talked about that. And sometimes also you want to prepare the data for further analysis. That is the reason why we do discretization. So Discretization reduces the number of values for a given continuous attribute by dividing the range of the attribute into intervals. The interval label can then be used to replace the actual value. So that's the whole idea of discretization. So instead of using um, large numbers or big numbers, you can reduce it into, you can redivide it and then use that intervals as the replacement for the actual data. We also have concept hierarchies. That's reduce the data by collecting and replacing low-level concepts, such as numerical value for attribute age, by higher level, such as a young, middle age, or senior. So what we are saying in excess is that um, if you have high concept levels, especially fuzzy levels, fuzzy concepts such as young. When we say young, we don't really know how young is the young. There's a player, I think the oldest player in Aston Villa right now, his name is Young, whereas is the oldest player in the place. So how young is young? We don't know, you know. So and stuff like also middle age. How do we define middle age? How do we define senior? So what we're saying now is that you can actually create, or you can have age, and um, when you have age, you can use age to now replace such kind of concepts. You may be wondering how can you use age and to replace high level concept. It is possible in your data connection that you have age and you still have um, 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 sorry, maybe rank in your assets. So what we're saying is that you can use one to replace the other. So hierarchical and recursive decomposition use binning, histogram analysis, and clustering analysis. So that is what they use. And we also have entropy-based discretization and segmentation by natural partitioning. All of these are used for discretization. For hierarchical generation using categorical data, when we say categorical data, it means that there's no ordering among the values. Especially when we say it could be like male, female, and like we saw earlier, young, middle age, middle class, seniors. All those ones are categorical data, but they don't have any order. There's no order between male and female. There's no order between student and maybe parents. It's only you that think there is such order. As far as computer is concerned, there's nothing like that. So the specification of partial ordering of attribute explicitly at the schema level by user or expert. So that's what I'm saying. It's only you that know that senior is higher than middle age. It is only the person that built the experts that know that kind of thing. The computer doesn't. Specification of portion of hierarchy by explicit data regrouping. So that is now you enforcing it on the computer. Specification of data attributes of specification of a set of attributes, but not of their partial ordering, and specification of only partial sets of attributes. So concept hierarchy can be automatically generated based on number of distinct value per attribute in the given attribute set. The attribute with the most distinct value is placed at the lowest level of the hierarchy. So, so we can say, like, for instance, a country. So country may have 15 distinct values. Then we have province or state, which may now have like 65. Then we have city, which have larger number, and street. So this is what a concept hierarchical method looks like. So in summary, data preparation is a big issue for both warehouse and data mining, and even for machine learning experts. You first need to ask yourself question about data before you start asking what machine learning model am I going to use or employ for this task. The first question to answer is the question of data. Then Your preparation for data includes or must include data cleaning and data integration, data reduction and feature selection, and discretization. A lot of models have been built but it's still an active area of research. So um, handling data alone is an area of research. That is what uh, we are actually saying. All right, so this is the end of my presentation. We still have quite some times. I wish we could have time to discuss on data. All right, so is there any question? Let me come to questions. Hello.
Thank you, sir. Engineer Ika, we highly we highly respect your presence here and the knowledge you impact in our to us today. We highly respect that. Thank you very much, sir. If you have any question, kindly signify in any order, and he will attend to that. Is there any question?
Okay, looks like there's no question. Okay, somebody. Oh, people have started raising up hands. Okay. Can we start with Mr. Usman? Sorry, I may not
Okay,
pronounce
man.
it. Okay, man.
Okay,
Okay, yeah.
man.
Good evening, all.
Good evening, sir.
Hello, good evening, all.
Good evening, sir. We can hear you. Please go ahead.
All right, thank you very much. Yes, thank you for the well-delivered lecture. It was really captivating and we learned a lot. Please, I want you to help me shed more light on how we can apply data mining to biological processes. I understand we have databases for some of the biological processes that we have. And I was glad if you could share more light on how we can take advantage of it. Thank you.
Sorry, please, can you come again? I couldn't hear you. There was a noise
Okay,
at the
okay, sir. I want you to help us shed more light on how we can apply data mining to biological processes.
Okay,
I
data
understand we
mining.
have databases. Yes, I understand we have databases now for some biological processes and even organisms. But please, if you could share more light on how we can take advantage of data mining, especially those of us in biological sciences. Thank you,
Okay,
sir.
can you give me an example of the biological process?
Okay,
Example of
for
bio.
example, we have a lot of proteins. We have a lot of proteins currently, and I understand we have a protein database where we can go to extract information about these proteins.
Okay,
Okay. Yes, sir.
okay,
So I'm trying to see if there are other ways we can apply it. If you could just shed more light on other ways we can apply it and, take advantage of acquiring the skill.
okay. Okay, well, thank you very much. I'll just give my opinion. Biological process, especially when you mention protein now, is not my field, and I don't know the process that is used. But I'll just give general opinion in that of course, since there are databases, that means that we can have access to, if especially if they give it, we can have access to download the data set, I mean the data set from the database, you know. So if we have an opportunity to download, that's interesting. You don't even need to have a data mining for yourself because they have done the tedious work of data mining. You know, you only need to download the data, then go into data preparation such as data cleaning. Of course, you may not even need data integration except if you are downloading from different databases. Yeah, I understand there are, you probably have many different, I mean, you have different databases. So you may also Probably you download from different databases now. You may need to do data integration, reduction, and the likes. Now, but it is also possible. Now, I don't know if this one I'm about to say really apply to you, but it is, let's say that some people publish their protein sequences in papers, and it is possible for you to actually mine those protein sequences from the paper that is published. Yeah. So what you can do now is, I mean, if that is the case, of course, you can develop some maybe natural language machine learning models. So what you do is you can keep listening to some particular journal publishing house. What I mean by listening is that you can build a web crawling, maybe using Python, that will be looking for specific papers on maybe protein sequence. So when you hear protein sequence, you can, you can download the paper, apply natural language processing to it, and those protein sequences will be extracted from the paper and saved um, in your own hard disk, or any memory space that you are using. So that's another way you can. What I'm saying in excess is that, number one, um, you can download data from the databases that you say you have. I mean, they are in existence, and you can integrate them together and apply everything we have talked about here today to it, to ensure that your data is in correct format, is not a dirty data. And number two is that you can even mine the data sets by yourself. If, for instance, the data is published in papers, so you can listen for those data for those papers, write machine learning models that will help you to extract the data from the paper, and then you can save it. So that's what I can give. Again, I'm not so much of an expert in this biological area, but is that a little bit okay?
Yes,
Does that
it is.
answer?
Thank you very much, sir. You've given me other alternatives and strategies on how to take advantage of it already. Thank you very much, sir.
You're welcome, sir. Thank you. All right. I think I see someone raised up his hand earlier, but he has dropped it. But I'm seeing Abdul. Okay, sorry. I think the person is up again. Let me take Mr. Ismail Adepoju.
Okay, good evening, sir. Good evening, everyone. Thank you very much for giving us that wonderful presentation. We really appreciate your efforts. May Almighty God grant you success in all your endeavor. My question is not really bogus. It's just something simple, but looking at it from a layman, it was about providing solutions to data that are too much in our database. So you made mention of reducing the data, and I'm not too clear with that because what I know is that if we are trying to compress data, I'm looking at it that are we not going to be having our outcome to be devaluated, to be devalued, you understand? So that's just basically my question, sir.
Okay, thank you very much. That's an interesting question and a good concern. But before I answer your question, I'm just going through the participant now, and I'm seeing my ogas and lecturers here. I thank you very much for joining. Dr. Habib, Prof. Mr. Sonny, thank you very much for coming. I'm so glad to see you. Thank you very much. Okay, so let me answer your question about reduction and whether we have the data devalued. Well, the data will not be devalued. We are going to have reduction. But what we are taking away is the features that, whether they are there or they are not there, their effect is not seen. That exactly is what feature reduction is all about. Or we have a better representation of this feature than if the feature were to be available. I talked about that it is possible to have a feature that summarizes other 4 or 5 features. Those kind of features are called salient features. or latent features. They are very important and they are taken advantage of. Now, let me clear your doubts by saying that if you take your phone now and you snap a picture and you send it to your friend using WhatsApp and your friend download it on your, of course, if you compare the two pictures together, you won't notice much difference. But if you look at the size of the data, I mean of the picture that you just took, maybe on your phone it will be some sort of 4.5 MB, but the one your friend download on WhatsApp, it may be some 415 or 512 kilobytes. What has happened? So much data reduction has happened, but the quality of the data that you are still looking at is the same. So there are different methods that are used to do that. Someone shared a particular software with me of recent that um, it can compress a 5 gig video into say 200 MB, and you will not see any difference. So these are some of the things that people are doing, especially people using auto encoder, decoder, and different variant of it that is currently in vogue. So it is possible to reduce your data without any devaluation or loss of data, both in quality. The only thing that will be reduced is the data, is the memory value which you want to preserve. All right, so thank you very much for the question. Okay, I hope that answer your question, Sarah.
Yes, sir. Thank you very much. I now have a clear understanding about how everything works now. Thank you very much, sir.
Okay, so let me hear Mr. So just permit me to use Meta because I now know that there are big people in this class, not just so just permit me to use Mr. Abdul Semi. Sorry, I can't pronounce it more than that. But do you still want to ask your question, Mr. Abdul Semi? Okay, maybe it's not available. Mr. Yusuf Ajani. Mr. Yusuf Ajani,
Good
I see
evening.
your. Yes, sir. Good
Yes, sir.
evening.
Good evening. Thank you very much for this wonderful lecture. Actually, I joined in between. I was able to catch something on some nominal data. Now, my concern is using this for, I don't know if you can hear me, sir.
Yes, I can hear you, sir.
All right, so my concern is using this in our own social sciences construct. And the reason is when we have nominal data sometimes, let's take age, for instance. And we actually need to convert it to when our nominal data is in categorical variable, we need to change it to continuous data. Is that actually possible when we subject this to doing our analysis under artificial intelligence?
Yes, sir, it is. It is very, very possible. And, that's why we're saying that AI is for everyone. All of us can. Um, but the landing page for us, which everybody now have to bring in their expertise, is how do you undo your data? Of course, your data is different from my data. I may not even understand the data you have from social sciences and all, but you can convert your categorical or nominal data to numerical data. I go over some of the methods that you can use. Let me go back to just see. Yes, so in fact, you can use binning method. Binning is like histogram. You are catching the data, you are partitioning the data together, and you can even use histogram analysis to convert them to numbers. You can also perform clustering to convert them to numbers. So all of these are possible. You can use them to convert your nominal data to numerical data, or even categorical data to numerical data. And I also want to say that it is especially the issue of converting categorical to numerical is not peculiar to social science. We all do it, you know. you get some information that you think is very important, but they are not numerical. They are not numerical. They are not even necessarily a true or false something, so that you can represent with 0 or 1. So, but we always need to perform this kind of conversion, numerical to, categorical or ordinal to numerical. Okay, I hope that answers your question, sir.
All right, so thank you very much, sir.
Yes, sir. Okay. Mr. Abdulsamid, do you still want to answer? Ask
Yes,
your
sir. Yes,
okay,
sir.
sir.
Thank you very much for the presentation, sir.
Yes, sir.
Can you hear me, sir?
Yes, I can hear you, sir.
Thank you, sir. Sir, I want to ask how important is data normalization? Because recently we did a machine learning model, and we intend to apply a Z-score to normalize the data. And we discovered that the initial data without the Z-score normalization has a better performance than when we have normalized the data. So I want to ask, is it that we should be normalizing our data always, or it depends on the way the data is? So I want you to shed more light on that. Thank you, sir.
Thank you very much. Yes, you see, in machine learning, the metrics you use to check how your model performs, whether good or bad, also matters. And then where you are checking how the model perform also matter. What I mean is that maybe you are checking the accuracy of your model, and you are checking the accuracy of the model on test data. Now, what you should not forget is that your test data all come from the same place. They have the same, they have probably the same dimension, the same range, and all of that. But if you sample your test data very well, it may come from outside of that kind of distribution. And when you apply your model on a test data, you just find out that it doesn't perform very well. So normalization is very important. If you are building a model that you will be deployed in a real world, and I cannot stress that enough, if you are building a model that you will deploy in a real world, you must perform data normalization. If you don't, your model will be dead on arrival, because there will be calibration issue. Let me try and give just think of an example. Again, don't forget that when we are saying normalization, what we are saying is we want to force this data to assume a specific narrow range of values. So if you don't force it to do that, if you deploy your model maybe using another kind of sensor, if you are interested in IoT data, if you use another kind of sensor, you have to take that sensor calibration into consideration for your model to perform well. But if your model has been trained on a normalized data, and when you bring in a new sensor into the case, you also have to normalize the sensor readings, right? The sensor data before you feed it into your model. But what you find out is that the model will perform as good as if you were using a sensor that you have not seen before. So that is where normalization comes in. Yes, and again, let me say that most of the time when we do normalization, especially on time series data, what we usually forget is that you have to unnormalize the data if you are going to see the correlation between what you have and what you are getting. What I mean by that is that sometimes people want to use time series prediction, and they normalize their time series data. But when they go into testing the data, maybe applying it on the test data, they forget to normalize the test data or apply the same normalization techniques on test data. And when they see the output is not correlating, and then they will say that the model failed, it failed. No, the model did not fail. the way we apply normalization is what is faulty. So when you are applying normalization, just put some things into consideration, and that's going to improve the performance of your model. I hope that answer your question, sir.
الصلاة والسلام على رسول الله وعلى آله وصحبه أجمعين. سبحان الله